Hello there, Mr. Sutton here, bringing you the IM3 Extra Practice number 2 solutions on dividing complex numbers. And it looks like this one's got a puzzle. Let's check that out. So here's the puzzle that goes with our extra practice. In this one, we're trying to solve the riddle, what do you get from a pampered cow? So we have some expressions on the left that we need to simplify, and we have to match them up with the simplified versions over here represented by letters on the right side. Whatever match we get, we're just going to put that letter above the number in these blanks down below. For example, if I do question 1 and let's say that ends up being choice P. I don't know that it is or not, but let's just pretend. Then I would put a P above the 1 down here. So let's get going with this and see what the answer to that riddle could be. All right, let's kick it off with our first problem, trying to simplify 8 over I. Now, the reason this problem and the others on the handout are not considered simplified is we're not supposed to have an I, an imaginary number, in the denominator, because that counts as a radical, and we don't want those there either. So I can fix this problem by just multiplying by something over itself, in this case, I over I. That gives me an 8I in the numerator and an I squared in the denominator, and this helps me because I squared is really negative 1. So 8I over negative 1 is just going to be negative 8I, which is what I predicted it would be, actually. I didn't even realize that was going to be the answer. But that's a P, so we're putting a P in spot number 1. For this next one, I've got a 3I in the denominator, but I can still get away with just multiplying by I over I. So I'll have a negative 4I in the numerator, 3I squared in the denominator, and then that I squared is really a negative 1, so that's a negative 3 down there. So I didn't really need to mess with the 3 at all to get rid of the imaginary number. And then I do need to get rid of these negatives to match one of the answer choices. So 4I over 3, which is going to match up with choice O, putting that in the 2 spot. For this next problem, before I go ahead and multiply by i's or anything like that, notice that this I squared in the denominator can already be turned into a negative 1. So that's really a negative 10 we have down there. And all I have to do at this point now is just reduce the fraction. So 5 over 10, that reduces to 1 over 2. So I can just call this I over 2 and make that whole thing negative. So negative I over 2, that's going to be D. So 3 is D. Hey, 3D. On number 4, things have gotten a little more complicated. Now I have not one but 2 terms in my denominator, which means that I can't just multiply by I anymore. If I multiply this denominator by I, the 2I squared will be fine, but then I'll have a 1I that I have to deal with, and I'll just be going back and forth forever. So instead, I'm going to multiply by the conjugate of my denominator, basically same numbers, opposite signs for the imaginary part. So I'll multiply by 1 plus 2I over itself. And if you're having trouble remembering why this is a good idea, really what we're doing is if you have A minus B times A plus B kind of situation, you can turn that into A squared minus B squared. We can basically square both of these, and that'll allow us to completely avoid having any I to the first powers down there. So let's do this one step at a time. Numerator first. So we have to distribute the 3 to both of those things up there. 3 times 1 is 3. 3 times 2I is 6I. And then down here, squaring the first thing gives me 1 squared, or just 1. Squaring 2I gives me 4I squared. And we always put a minus in the middle when we do the A squared minus B squared dance. Now this I squared, we know that's really negative 1. So I'm really doing 1 plus 4 when all is said and done down there. Which means we really just have 5 in the denominator. Taking a quick look to see if I can reduce this any further, 3, 6, and 5, there's no common factors that all 3 of those share. So this is as good as it gets. And I'm looking for 3 plus 6i over 5. That's going to be an L. So I'll put that in spot 4. So this spot gets an L. And there's actually another 4 over here. We get to use this one twice. So there's another L for us on this one. For this next problem, we have 2 terms in the denominator. So to simplify this, we're going to do what we did on number 4 and multiply by the conjugate. So I'm going to do 2 minus 3i over itself. Dealing with my numerator first, negative 3i distributed to both of those. So negative 3i times 2 is negative 6i. Negative 3i times negative 3i is a positive 9i squared. And now for the denominator, again, I can use my a squared minus b squared shortcut with these. So 2 squared is 4, 3i squared is 9i squared, which we're going to be subtracting. Now I can do some simplifying. In the numerator, I can turn this 9i squared into a negative 9. Again, I squared is negative 1. And then in the denominator, this negative 9i squared now becomes a positive 9. So 4 plus 9. 4 plus 9 is 13, so that's not so bad. And then 9, 6, and 13, no common factors for those. So this is as good as it gets. It looks like that's choice I over here on the right side. So 5 is getting an I, and there's another 5 actually that we have to give the I to as well. Here we have another problem with two things in the denominator. So let me use my conjugate trick. Again, we're using the denominator's conjugate, not the numerator's. So I'm going to be doing 3 plus I over itself, not 2 minus 5i. Now, with the numerator, I have to basically FOIL these together. You can pretend there's some invisible parentheses around the 2 plus 5i and the 3 plus I. So we've got 2 times 3, which is 6. 2 times I is 2i. 5i times 3, that's going to be a plus 15i. And then 5i times I gives me a plus 5i squared. In the denominator, I can just use my a squared minus b squared shortcut. So 3 squared is 9. I squared is, well, I squared, and we'll be subtracting that. Let me simplify my I squareds next. So in the numerator, this 5i squared is going to become a negative 5. In the denominator, we're going to have 9 plus 1. Simplifying even further, in the numerator, 6 minus 5 gives me a 1. 2i plus 15i is a plus 17i. And downstairs we've got 9 plus 1, which is 10. And that can't be simplified any further. So that looks like it's going to be choice K. So this was number 6. So 6 there is K. For number 7, we've got two terms in the denominator. So let me multiply by the conjugate of the denominator. So that would be 4 plus 5i over itself. For the numerator, let's FOIL those out like we did on the last couple problems. So 6 times 4 gives me 24. 6 times 5i is plus 30i. Negative 2i times 4 is negative 8i. And negative 2i times 5i, that's going to be a negative 10i squared. Downstairs, let me use my a squared minus b squared shortcut. 4 squared is 16. 5i squared is 25i squared, and we've got minus that. Let's simplify my I squareds. In the numerator, this negative 10i squared is now going to become a positive 10 because I squared is negative 1. Downstairs, instead of negative 25i squared, we can write plus 25. Back upstairs, 24 plus 10, we can combine that to 34. 30i minus 8i is going to be a plus 22i. And now in the denominator, 16 plus 25 gives me 41. So I don't think there's any common factors between any of those. So let me just take that as it is and match it up. That looks like E over here on the left. This was number 7, so then 7 is E. For this next problem, things are getting stranger and stranger. Not only do we have two terms in my denominator, but now we've got some radicals to mess around with. I'm still going to use the same trick though, multiply by the conjugate of the denominator. So in this case, we're multiplying by radical 2 minus I radical 3 over itself. And now in the numerator, let's go ahead and distribute that radical 3. Radical 3 times radical 2, multiply the stuff inside, that's radical 6. And then root 3 times I root 3, well, radical 3 times itself is just square root of 9, which is 3. So this is just negative I times 3, or negative 3i. In the denominator, I can now square both of these things using my a squared minus b squared shortcut. Radical 2 squared is just 2, because when you square a radical, you get what's inside. I radical 3 squared, I'm going to have an I squared times 3, and I'll have a minus in front of all that because it's minus b squared, so minus 3i squared. Simplifying that negative 3i squared, I'm really going to have 2 plus 3 down there. And then 2 plus 3 is just 5, so no big changes there. I can match this up now with one of my answer choices. So we have a root 6, a minus 3i, and a 5. That goes with S right there. So 8 is S. Well, we've made it to the final problem. Last boss battle here, number 9. Still got to multiply by the conjugate, but before I do that, I don't like this radical with a negative inside, so I'm going to take an I out of that to make that a positive inside. Now I'll use my conjugate trick. And this looks awfully familiar. I think we had this same denominator on number 8, so we're going to use the same conjugate. Radical 2 minus I radical 3. Different numerator though. So when we multiply this out, 2 getting distributed, we've got 2 radical 2, which is pretty easy to do. And then we have 2 times all that stuff there. That's a negative 2i radical 3 up there. In the denominator, again, squaring these two things, we're going to have a 2, because radical 2 squared is 2. We're going to be subtracting I squared times 3, so 3i squared. 3i squared minus 3i squared is really still plus 3, because I squared is still negative 1. 2 plus 3 is still 5. That has not changed. And I feel like I ought to be able to simplify this more. I've got all these 2's up here, but I can't. These radicals are different, and we have a real versus an imaginary number. 2, 2, and 5 don't have any common factors. So unfortunately, this is really as good as it gets. So that's going to be M going in spot number 9. And now that we've filled in all our letters, we can solve this puzzle. What do you get from a pampered cow? We get spoiled milk, right? If someone's pampered, they're spoiled, and you get milk from a cow. Well, you get it. All right, Mr. Sutton signing off.